All right. So, label notes for today, Monday, November 8th, and let's get started. All right. So, investigate. We're starting a new investigation. A symbolic rule showing how values of one variable can be calculated from values of another is a concise and simple way to represent a function. Mathematicians typically write the rules for linear functions in the form y equals mx plus b. Statisticians prefer the general form y equals a plus bx. In a linear function rule like y equals 3x plus 7, or equivalently y equals 7 plus 3x, the number 3 called the coefficient of x and the number 7 is called the constant term. You probably have several strategies for finding values of the constant term and the coefficient of x in rules for particular linear functions. As you complete the problems in this investigation, look for clues that will help you answer the basic questions. How do you use the how to use the information in a table or a graph or the conditions of start over. Sorry. How do you use information in a table, a graph, or the conditions of a problem to write a symbolic rule for a linear function? All right, so what I want you to write, make sure you write this in your notes. This is the part I want you to write down. So symbolic rule, y equals mx plus b, because we're gonna be using this mostly in math. We're not going to be talking about statistics with this. M is the coefficient, and b is a constant term. So go ahead and pause it, write this down, make sure this is your notes. All right, so jumping right into example one, here's some background information for our first example. So Dunkin' Booth's profits. So the student council at Eastern High School decided to rent a Dunkin' booth for a fundraiser. They are quite sure that students would pay for chances to hit a target with a ball to dunk a teacher or administrator in a tub of cold water. The dunking booth costs $150 to rent for the event, and the student council decided to charge students 50 cents per throw. So we're gonna highlight those two things because that's going to be our information that we really need to pay attention to. Costs $150 and 50 cents per throw. Okay, let's jump into it. How do you know from the problem description that profit is a linear function of the number of throws? So how would you know? So if we look at this right here, this line right here, it says 50 cents per throw. It's implying that we have a constant rate of change, right? We talked about constant rate of change in the last investigation. So when we see this, let's write this: 50 cents per throw constant rate of change. And we have a constant rate of change that is linear. And we're increasing by the same amount every single time. So we're going to use the words now and next to write a rule showing how fundraiser profits change with the additional customer, right? With each additional customer. Right, so we have next equals now. We wanted to write starting at. This is what we have to write for every now next equation. So starting at blank and blank. All right, so let's go back to our information here. So the dunking booth costs $150 to rent for the event, and the student council decided to charge 50 cents per throw. All right, so what number is going to go right next to the word now? You should be thinking now plus 50 cents. So we can write plus, because we're increasing by 50 cents. The student council is charging 50 cents per throw. And we're starting at, the student council is starting at negative 150 because they had to pay to get the dunking the dunk words why the machine that allows you to dunk like Mr. Siegel or Mr. Yates or Mr. Halterman, right? So our rule is going to look like this. Make sure you have this written in your notes. Next equals now plus 50 cents starting at negative 150. All right, so we're going to write a rule that shows how to calculate the profit P in dollars if T throws are purchased, right? Explain the thinking the way you wrote it. Explain your thinking. Right, so we're going to write P, right, because that's how much money we're going to have at the end. equals, and then t is going to be our other variable. We're not going to use y and x, we're going to use p and t, right? So where did we start? Right, remember, going back to our notes, we have a constant and a coefficient of x, right? So what we're going to write, our constant is just going to be like, that's going to be the number that's all, it's not going to change, right? Our number that doesn't change is negative 150, because we have to pay, no matter what, we have to pay $150 to get the machine to our fundraiser. And we're going to be earning, so we're gaining money back, 50 cents per throw. And T is going to be the number of throws, right? So if we have like 50 people paying, we're gonna plug in 50 for T. So actually, let's not use parentheses. So our equation is going to look like this: P equals 50 cents times T minus 150. Right, so what do the coefficients of t and the constant term in your rule from the part C tell about the graph of the profit as a function of the number of throws, right? So what does it tell you about the graph, right? What do you notice about the graph? Coefficient. All right, so if you look at this, right, so this is another way to describe this coefficient is like our slope. So this would be tell us our 50 cents tells us our slope, and the negative 150 is going to be our y-intercept. Right, so if you were to graph this, our line would look something like this, because we're crossing at 150, and we're increasing by 50 cents per throw. All right, so again, what does the two numbers in our equation tell us about, right? So our constant term, right? So if this, our constant term, right, this would be, if we had a table, the negative 150 would be the number where the 0 was, right? So if we had, our profit was, let's do throws and profit down here, this would tell us that, hey, that's going to be our profit for when we have 0 throws. And the 50 is going to tell us how much we're increasing by, right? So if I have 1 throw, my next one is going to be negative 145.5. And then 2 throws would be negative, sorry, that's supposed to be negative 144. And this would be negative 144, right? I'm adding 50 cents with every throw. Okay, right, so that's number 1. Let's talk about number 2. All right, so every business has to deal with 2 important patterns of change called the depreciation and inflation, right? So depreciation is basically the value of an item is going down. So like if you buy a new vehicle, like a truck, like the value of that truck is going down the moment you drive that off the lot. And you also have inflation, right? So the price of something going up. So you think of like gas prices recently. Stock market generally goes up 7% every year in the long run, right? So when we talk about equipment and purchased and resale value of that equipment declines or depreciates as time passes. So let's go and highlight this, right? So we have depreciates as time passes. So when you talk about depreciation, the equipment it declines. The cost of buying new replacement equipment usually increases due to inflation as time passes, right? So when you think increases, you should be thinking inflation. Erase this. And we think where is it? Depreciation. Oop, not that one. I wanted to highlight it. Depreciate declines. Okay, so the owners of Game Time Incorporated operate a chain of video games arcades. They keep a close eye on prices for new arcade games and the resale value of their existing games. One set of predictions is shown in the graph below. All right, so let's go and take a look at this graph. All right, so which of the 2 linear functions predicts the future price of new arcade games, and which predicts the future resale value of the arcade games that are purchased now? All right, so remember, when we talk about depreciation, it's going to be our value is going down. And when we're talking about inflation, our price is going up. So we want to talk about, let's see, red. All right, so which of the 2 linear predicts the future price of the new arcade game? So the future price, we're talking about future price, that's going to be like, it's going to be inflated. So we're talking about future price, let's go right. Future price I would say this line here, graph line 1, right? Because it's going to be increasing. My slope is increasing, my line is going up. And we're talking about which predicts the future resale value of arcade games that are purchased now. So future resale value, I would say that this is going to be line 2, because as it's going down, it's depreciating, right? The value of that arcade game is going down generally. Okay. All right. So part B, we went for each graph. Find the slope and y-intercept. Explain these values. Tell about the arcade games, right? So if we talk about the y-intercept for both of these is going to be right here. So the y-intercept for both, I'm just going to say y-intercept for both equals $500. But the slope is going to be different for both, right? So we have 1, I'm going to call this 1m equals, and we'll call this 2m, because m is typically a symbol for our slope. Right, so if we look at this, right, so I'm going, another way to describe slope is rise over run. So I'm going to go and, like I can say my rise, I'm going up 100, and I'm going to the right 2. Right, so my slope is going to be 100 divided by 2, and I can simplify that. So my slope would be 50 per year. So the slope for line 1 is 50. Let's just pick 2 points on the line here. So I'm going to go this point here, and we'll go back to the same point. So I'm going down. This is going down 200 because I'm starting up. This is 500 here. And I'm going down to 400, 300, right? And then my run, again, is going to be 1.5. So I would have to go negative 200. That's my rise. I'm going down 200. And my run is 1.5. We can simplify this. Okay, so we have negative 200 divided by 1.5. It's going to be negative 133.333. So that's going to be repeating. So we're going to write, we'll write negative 133.3 with a line over that. Right? So my slope is going to look like this. Perfect. All right, so basically what it's saying, like they both have a starting value. Like right now, we expect the price of the arcade game to be $500. Right, that's what our y-intercept is telling us. That's our starting point. If we don't buy the arcade machine now, we would expect the price to go up $50 per year. Okay, the price of a new arcade game, if I need to buy a new one next year, we would expect it to be $550. And the year after that, it's going to be 50 plus 550 would be $600. And if I were to talk about this one right here, the value of the arcade game I buy right now would decrease by $133.33. So if we go and take a look, that'd be 500 minus 133.3. So I would expect the value of that arcade game to be $366.70, give or take. All right, so I'm going to write rules for calculating the game price in dollars at any future time in years, right? So write a rule for calculating game price P in dollars at any future time in T years. So we're going to do it for both, right? We'll call this line I, which is our starting one, and I'll do this in blue because that's the line here. Okay, so this is, again, my price is going to be P. We had our starting point was for both is going to be 500, and my slope for this would be 50. And then it was after T years. So we have 50T plus 500. And then for my second line, it's going to look like this, right? We have P equals, again, my starting point is the same, but instead of increasing by 50, we're now decreasing by 133.3 T. It's going to look something like that, right? Because again, our lines are decreasing. Okay, let's try our last problem, right? So the Terrapin Candy Company sells its specialty turtles made from pecan caramel and chocolate through orders placed online. The company webpage shows a table of prices for sample orders. Each price includes a fixed shipping and handling cost plus a cost per box of candy. All right, so we have our table here. I'm going to explain why the price seems to be a linear function of the number of boxes ordered, right? So if you take a look, on the top we're increasing by 1 every time. And then on the bottom, we're increasing by 5. By 15, sorry, not 5. So let me erase this. And we're going from 20 to 35, that's plus 15. From 35 to 50, that's plus 15. And then from 50 to 65, that's plus 15. And then from 65 to 80, that's plus 15. So we have a constant rate of change. Okay. What is the rate of change in order the price as what is the rate of change in order price as the number of boxes increases, right? So what's happening was for every number of box I order, the price increases by $15. Okay. All right, so we're going to write a rule for calculating the price P in dollars for the number of boxes N. We're going to use P and N for our equation here. All right, so again, my price is P. Remember, okay, so we know that I'm increasing by 15 every single time, but we need to figure out how much what's our starting point? What's going to be the price for $0? For 0 boxes, right? So if we were to go, for going forward, we're adding 15. To go backwards, to find 0, I need to subtract 15. Subtract 15. Let me make that a little more clear. Subtract minus 15. So 20 minus 15 is going to be 5. So we're starting at 5. Okay. All right, so you're going to use your rule to find the price for 6 boxes and the price for 9 boxes of turtles, right? So we can either follow our pattern, or we could just plug it right in, right? So we can say 15. We want to know the number of 6 boxes. So let me make that a different color to make it really obvious what we're doing. I'm going to do 6 boxes. Let's go back to blue. Plus 5. So 6. We can actually not. We're just going to go straight to our calculator here. We can just go 15 times 6 plus 5. So we'd pay $95. All right. And if I want to find, it's saying for 9 boxes, I would do 15 times 9 plus 5. That would be 140. 140. So we do 15 times 9 plus 5 equals 140. Okay. All right. Well, that is it for this lesson. We're going to be looking at taking a quiz after we come back from Veterans Day. Probably Tuesday, if I would guess, maybe Wednesday. If you have any questions, please send some questions to me via email. I'm going to be out for the next 3 days and the week after that, and then I'll be back. I should be back in class after Thanksgiving break. So I will see you later. Have a great day.